It's funny how we always think big health scares,
Yeah.
like they're going to be this far off thing,
Yeah.
happening somewhere else. But then early 2024 rolls around and boom, bird flu pops up in dairy cows.
Oh, yeah.
Right here in the U.S., in the Texas Panhandle of all places.
Wow.
And what made that so freaky was that it jumped to a mammal that, we're in contact with all the time.
Yeah, we are.
I mean, really close contact.
Right.
And it just makes you think like, whoa, what else is possible?
Yeah. Virologist Thomas Friedrich, he said it best when he said, holy cow.
It did.
He said, this is how pandemics start.
Yeah, that's pretty chilling when you think about it.
It is.
To kind of zoom out a bit, this bird flu is the H5N1 strain, and it's not exactly new news.
Right.
It's been considered an animal pandemic, a panzootic, for a while now.
Okay.
Hitting bird populations all over the world.
Wow.
Except for Australia.
Huh.
And what's really crazy is the sheer number of mammals it's infected globally. I mean, we're talking everything from house cats
to farm goats, to mink, and even wild animals like tigers and seals and dolphins.
Oh, wow.
And you hit the nail on the head. The U.S. is the only country so far with H5N1 in dairy cows, and it's spread to at least 17 states already.
It's just so hard to wrap your head around how widespread it is.
It is.
And this isn't some new thing that just popped up. H5N1's been around since the 90s.
Oh, wow.
So we're talking about a problem that's been simmering for almost 3 decades.
Right.
Veterinary researcher Maurice Patesky really put it in perspective when he said, this is the largest animal disease outbreak we've ever had.
That's crazy.
When you consider all the animal diseases out there,
Yeah.
that statement is huge.
It is.
So the main thing here is that this is not going away anytime soon.
Yeah, and we're seeing the effects already, aren't we?
Yeah.
The poultry industry's been hit hard, and now dairy's facing this new challenge.
Right.
I mean, we've all seen those egg prices fluctuate like crazy.
Yeah.
And the thing is, this goes beyond economics. There are real human health risks here we need to understand.
We do.
Yeah.
Let's talk about the human side of this, because while the risk might seem low right now,
Yeah.
the historical data is pretty scary.
It is.
Over 960 human infections globally since 2003.
Wow.
And about half of those were fatal.
Right.
And more recently, since the start of 2024, the U.S. has seen dozens of infections.
Yeah.
Mostly among farm workers.
Right.
And we had our first death in January 2025.
That's right.
I mean, that really shows how dangerous this virus can be when it jumps to humans.
Absolutely. But it's really important to stress that right now, both the CDC and the WHO say the public health risk is low.
Okay.
And the main reason is that the virus hasn't figured out how to easily spread from person to person yet.
Okay.
That's the big one.
Yeah.
But we can't get complacent. Virus ecologist Michelle Will said it perfectly.
Yeah.
The thing about this virus is every time we think we know what's going to happen, it does something totally unexpected.
Yeah.
And that's the only consistent thing I can say about it.
I see what you mean.
That unpredictability is what makes this such a big deal.
It is.
So with all of this happening, the jump to cows, the spread in animals, the human infections.
Right.
Our goal today is to really break this whole thing down.
Yeah.
We want to understand the nuts and bolts of this bird flu,
Right.
trace how it's traveled,
Okay.
and look at what could happen based on what we know now.
Okay, cool. So let's start with the basics.
Sure.
What is this H5N1 virus?
Okay.
Like, what's the biology behind it?
Okay, so H5N1, it's an influenza virus,
Okay.
which puts it in the same family as the flea viruses we see in wild birds.
Okay.
And interestingly, also in bats.
Huh?
They're actually pretty simple in structure, but very effective.
Okay.
They have 8 pieces of genetic material that code for 11 different proteins.
So like 11 proteins.
Yeah.
From just 8 pieces of genetic material.
Exactly. It's like,
That's efficient.
it is very efficient, yeah.
Wow.
And of these proteins, there are 2 on the outside that are super important. Hemagglutinin, or H, and neuraminidase, or N.
Okay.
Think of H like a key that lets the virus grab onto sugar molecules on the surface of a cell.
I see.
That's how it gets in.
Okay.
And N, it's like the escape hatch.
Okay.
It helps new virus particles detach from the infected cell so they can spread.
I got it.
So those are the main tools for invasion and spread.
So basically H and N are the virus's way of getting in and out.
Exactly.
So,
Now, what's really fascinating, and also what makes influenza A so tricky, is how much they vary.
okay.
Their genetic code is really fluid,
I see.
which leads to lots of diversity in their genes and proteins.
Okay.
This allows them to mutate and change over time.
Okay.
So they can infect different hosts and even dodge immune systems.
Wow.
This constant evolution is a big reason why we see these new threats popping up.
So H5N1 is just one version of influenza A then?
Yeah, basically. The influenza A virus has tons of possibilities for these H and M proteins.
I see.
We know of at least 19 different H versions and 11 of N. And most of these are found in flu strains that infect wild waterfowl.
Okay.
So H5N1 means it has the 5th version of hemagglutinin
Okay.
and the 1st version of neuraminidase.
Got it.
But don't forget, it has variations in other genes too,
Right.
which contribute to its overall personality, you could say.
I like that analogy.
Yeah.
So it's not just about the H5 and N1 labels.
Right.
There's a bigger genetic picture.
That's right.
And you mentioned mutation earlier. So how did these new flu viruses actually come about?
Okay, so one of the main ways is through gene swapping or reassortment.
Okay.
Imagine 2 different flu viruses infect the same cell at the same time.
Okay.
Their genetic material can mix and match when new virus particles are made.
I see.
This can lead to totally new combos of genes,
Okay.
and you end up with a brand new flu virus with different traits.
Wow.
It's like shuffling a deck of cards and getting a totally new hand.
I like that.
Yeah, so that's why influenza viruses can change so much and so fast.
It makes sense.
And why it's so hard to predict what new ones might pop up,
Yeah.
and why we need to keep a close eye on them.
Right.
So all kinds of influenza A can infect wild waterfowl,
Okay.
but they usually don't get them very sick.
Okay.
The viruses mostly hang out in their guts
Okay.
and spread through their droppings.
Right.
But when these viruses jump to other species that haven't evolved alongside them,
Yeah.
that's when we can see big problems.
Right. Like the outbreaks we're seeing now.
Exactly.
So H5N1's been around since the 90s, and it's been full of surprises.
Yeah, a lot of curveballs.
Yeah. One of the sources called it that.
Yeah,
So let's talk about its history.
sure.
What did scientists think about bird flu at first?
So the early thinking was that if bird flu jumped to poultry, it would cause a big outbreak in the flock,
Okay.
but it would be a one-time thing.
Like it would just disappear.
Yeah, Brian Richards from the USGS said they expected it to be super deadly,
Okay.
kill the birds quickly, and then basically run out of hosts to infect.
Okay.
So it would just burn itself out.
That makes sense.
Yeah, the idea was limited spread beyond that initial group.
Right. So it would just vanish.
Yeah, basically.
Okay.
And there was also this long-held belief about bird flu jumping to humans.
Okay.
Scientists thought that for it to infect people, it would need to adapt first in another animal.
Like a stepping stone.
Yeah, like a pig.
Okay.
Pigs can be infected by both bird and mammal flu viruses.
Right.
So the thinking was the bird virus could swap genes with a mammal flu in a pig,
Okay.
and that would help it get used to mammals.
Right.
So it was seen as a necessary step to become a threat to humans.
So basically an adaptation period in a middleman.
Yeah, exactly.
That is-
So when H5N1 first appeared in geese in China in 1996,
Right.
it worried the poultry industry, but not so much human health
Okay.
because of these assumptions.
Right.
But then 1997 in Hong Kong,
Right.
things changed.
Yeah, that really flipped the script, didn't it?
Oh, it totally did in 1997 in Hong Kong.
Yeah.
A 3-year-old boy died from this really bad respiratory illness.
Oh, wow.
And it took months for experts to figure out it was H5N1.
Right.
At first, no one believed it.
Right.
Robert Webster, a top virologist, he said,
Yeah.
a virus with an H5 was supposed to be a chicken virus.
Oh,
But this H5N1 went on to infect 18 people and kill 6.
it's terrible.
So the big takeaway here was that these bird viruses can jump right to humans.
Yeah.
No middleman needed.
Wow.
And that's a big deal for pandemic risk.
It is.
Yeah.
Webster even called it a nasty bastard,
He did.
which really shows how shocking and serious this direct jump was.
Yeah.
Friedrich said it blew everyone's mind because it proved humans could be directly infected.
Right. It totally changed how we think about these viruses.
It did.
Hong Kong acted fast and culled all their poultry.
Wow.
And it looked like they stopped that specific lineage of the virus.
So crisis averted, right?
You would think so, but the parent virus back in mainland China,
Oh, no.
it stuck around.
Oh,
Like
wow.
Brian Richards said, this wasn't the one and done.
Wow. So it kept going.
It kept circulating in poultry,
Right.
and there's still some human cases.
Okay.
Then in 2005, another big thing happened.
Okay.
The virus spilled back into wild birds
Oh.
at the Qinghai Lake Nature Reserve in China.
Wow.
But this time, it was super deadly.
Oh.
It caused mass die-offs in birds like geese and gulls and cormorants.
Oh, my gosh.
Yeah.
So now it wasn't just a threat to poultry.
Right.
It could also hit wild birds hard.
Exactly. And Richard said this was a key moment.
Really?
He said it set the stage for where we are today.
How so?
Because now the virus had this huge mobile reservoir,
I see.
wild birds,
Okay.
and maybe even some that had been around infected poultry.
Okay.
They could carry H5N1 far and wide along their migration routes.
Wow.
So it spread to Europe and Africa.
Okay.
And as it spread, it also evolved,
All right.
mixing and matching genes.
Okay.
Sometimes it's H5 part combined with different N subtypes, like N8.
So it was always changing.
Always adapting.
Right.
Then in late 2014, H5N8 showed up in North America,
Okay.
probably carried by birds migrating from Asia.
Okay.
It spread across some states, but eventually died out.
Okay.
But the problem of H5 viruses globally
Yeah.
didn't go away.
Right.
Mostly as H5N8 and sometimes H5N6.
Okay.
Then around 2020, infections in birds started increasing again.
Right.
And a new H5 variant popped up called 2.3.4.4b.
2.3.4.4b?
Yeah, it was first seen in the Netherlands.
Okay. And what's so special about 2.3.4.4b?
Well, Thomas Friedrich says that viruses with this variant seem to be better at jumping to mammals.
Oh, wow.
Then by 2021, this 2.3.4.4b variant,
Okay.
it combined with a form of the N1 neuraminidase.
Okay.
And like Michelle Will said,
Yeah.
from there we started seeing this mass spread event.
Wow.
So this new strain hit North America in late 2021,
Okay.
and this time it stuck around.
Oh, no.
This was the start of the panzootic we're dealing with now.
Wow. So it's been a long and complicated journey
It has.
and full of surprises for scientists. And now it's here in North America,
Right.
especially in poultry.
Yeah.
And we're seeing the results,
Yeah.
including that unexpected jump to cows.
That's right.
So how are we trying to manage and control this? Let's talk about biosecurity of vaccination.
Okay, so as birds migrate south,
Yeah.
they bring H5N1 to poultry farms.
Right.
And it's really deadly to chickens.
Okay.
So the main way to control it has been culling infected flocks.
So getting rid of them.
Yeah, in the U.S. alone, over 166 million chickens have been culled since 2022.
It's a huge number.
It is.
It really shows how big this problem is.
Yeah.
And to stop it from spreading more biosecurity on farms is crucial.
Oh, absolutely.
Right.
This means a bunch of things to prevent the virus from getting in and spreading, like limiting contact between people and birds,
Okay.
really strict hygiene like hand washing and special boots,
What?
and always using protective gear like masks and gowns.
Right.
But Maurice Petesky pointed out a big challenge. A lot of farms are close to water sources,
I see.
like lagoons and ponds,
Right.
which are natural spots for migrating birds.
Right.
So there's this constant risk of spillover from wild birds,
Right.
especially because the virus can live in bird droppings.
I see.
So it's a constant battle to keep wild birds away from the poultry.
Wow.
And to fight this threat, the USDA recently announced a ton of funding.
Yeah, they did.
In
that.
February 2025, they said they'd give up to $1 billion to fight avian flu.
Wow.
This money will go to a lot of things,
Okay.
like improving biosecurity on farms,
Okay.
helping farmers who've been hit by outbreaks,
Right.
and really importantly, speeding up research on vaccines.
Right. Vaccines, speaking of which.
Yeah.
We've had bird vaccines against H5 viruses for a while now, haven't we?
We have. They've been around for a couple of decades.
Okay.
And they get updated to match the new strains.
Okay.
The USDA also said they want to update their vaccine stockpile for chickens.
Okay.
And Zoetis, a big animal health company, they recently developed a new one based on a strain from 2022.
Right.
Mahesh Kumar from Zoetis says it's good at preventing symptoms and death in birds, but it doesn't necessarily stop them from getting infected or spreading it.
Oh, so they could still carry it,
They could.
even if they don't look sick.
Yeah, that's a big thing to think about when it comes to vaccine strategy.
Yeah, it is. So even vaccinated birds could still spread it
They could.
without even looking sick.
Yeah,
That seems like a big problem for controlling the spread.
it is. Yeah.
Older versions of these vaccines from Zoetis haven't been used much,
Right.
mostly in a few other countries,
Yeah.
and in one case in the U.S. in 2023,
Yeah.
to protect endangered California condors.
Right.
And just this year, in early 2025, the USDA gave Zoetis a conditional license for this new formula.
They did, but this is just one step.
Okay.
Doesn't mean they can start selling it everywhere just yet.
Okay.
The U.S. has been hesitant to use widespread poultry vaccination for highly pathogenic avian flu.
Yeah, I've heard that. Why is that?
Well, while poultry in the U.S. do get vaccinated for other common diseases,
Right.
there's been a lot of worry about using them for highly pathogenic flu like H5N1.
Yeah.
One big concern is that vaccines might hide infections.
Okay.
If birds don't look sick,
Yeah.
it's harder to tell if the virus is in a flock,
I see.
and that could be bad for international trade.
Right.
The U.S. exports a lot of poultry,
We do.
and other countries don't want birds that might be carrying H5N1.
Right.
So it's a tough choice.
It is?
Protect our flocks or keep our export markets.
Right.
But this new vaccine from Zoetis has a cool feature.
Oh, really?
It's designed to address that problem.
Okay. How does it work?
So they use the N2 neuraminidase protein instead of the N1
Okay.
in the vaccine.
Right.
N1 is what's in the circulating H5 viruses right now.
Right.
So this difference helps you tell apart birds that have antibodies from the vaccine,
Okay.
which means they were exposed to N2,
Right.
and those that have antibodies from the real virus,
Okay.
which would be N1. Okay, so you could test the birds
You could.
and see who's been vaccinated and who's actually infected.
Exactly. It's called the DVA strategy.
DVD.
Yeah, it stands for differentiating infected from vaccinated animals.
Cool.
So in theory, it's a solution.
Right.
But will the U.S. actually use widespread poultry vaccination?
Who knows?
It's still up in the air.
Right.
Maurice Pitesky thinks it depends on the broiler chicken farmers.
Okay.
They make up a lot of U.S. poultry sales.
Right.
If they don't want it, it probably won't happen.
I see.
Lucio Crespo even said the decision could be made state by state
Okay.
because different regions have different needs.
Yeah.
But Mahesh Kumar from Zoetis says they're ready to make a lot of vaccine quickly
Okay.
if the U.S. decides to go that route.
So we have the science,
We do.
but the decision to use it is complicated.
It is
Economics, logistics, trade, all that.
all of that.
Let's move on to the H5N1 in cows.
Okay.
That was a real shocker, wasn't it?
It was, yeah.
No one saw that coming. It really blindsided a lot of experts.
It did, yeah.
When it showed up in Texas dairy herds in early 2024,
Right.
Maurice Pitesky said, and I quote,
Okay.
"The literature suggested that dairy cows don't get influenza A's."
Right.
But he joked, cows don't read the literature.
Makes sense.
So the dairy industry was totally unprepared.
Right.
They didn't have the guidelines or biosecurity protocols that the poultry industry has built up over the years.
I see.
And there were reports that some dairies were slow to adopt biosecurity measures after the first cases.
That makes sense, though, right?
Yeah,
Why would they have protocols for a virus they never thought would affect them?
exactly.
So what does H5N1 do to these cows?
Well, the good news is most of them survive,
Okay.
but they need to be isolated,
Okay.
usually for weeks.
Okay.
Often in what they call hospital barns.
Okay.
The main symptom seems to be mastitis.
Mastitis?
Yeah, inflammation of the udder.
Okay.
So they produce this thick, yellowish milk. And that contaminated milk in the milking parlors,
Yeah.
it can spread the virus from cow to cow
I
through
see.
contact during milking.
Okay.
Interestingly, though, early research suggests that it doesn't usually cause widespread infection or respiratory problems in the cows.
Okay.
And so far, beef cattle haven't been affected.
That's a hit.
So it's mainly about milk production
Right.
and spread through infected milk. And the USDA has stepped in, hasn't it? They've made milk testing for H5N1 mandatory
Okay.
in all 48 states.
Wow. All of them.
Yeah, and sadly, this led to new cases in Nevada and Arizona
Oh, no.
in February 2025.
So it's spreading.
It is.
And what was significant about those new cases?
Well, the virus in those 2025 cases,
Yeah.
it was different from the one in Texas in 2024.
Really?
Yeah, the 2025 one is called the D1.1 variant.
D1.1.
And the 2024 one was the B3.13 variant.
Yeah.
Both are subvariants of the same bigger H5 lineage, 2.3.4.4b.
Right.
But this shows how fast these flu viruses can change
You did-
and swap genes.
Wow.
So even in a short time, we're seeing different versions jumping from birds to cows.
That's crazy.
It really highlights the constantly changing nature of these viruses
Yeah.
and how hard it is to track and control them.
So what happens now?
Yeah.
What are the long-term implications of H5N1 in cattle?
We don't really know yet.
Ah,
It's still being investigated.
right.
Jamie Jonker from the National Milk Producers Federation.
Okay.
He's hopeful that these were isolated events
Okay.
and that we won't see widespread spread in dairy herds.
I hope he's right.
Yeah, but he also said the dairy industry really wants a vaccine
Okay.
as a preventative measure,
Right.
even if they don't need it right away.
Makes sense.
Zoetis and other groups are working on H5N1 vaccines for cows.
Okay.
But it's early days.
Right.
We don't know how well they'll work or how widely they'll be used.
Okay.
But Gregory Gray has a more cautious view.
Okay.
He said, we may not be able to put out this fire. And he raised the possibility of the virus becoming endemic in cattle.
Endemic.
Yeah, meaning it could become a permanent fixture.
Oh, no.
So it could be a constant problem for the dairy industry.
That's not good.
No, it's not.
Okay, so now for the big question,
Right.
the one everyone's thinking.
Yeah.
What does all this mean for us?
Right.
What's the risk to human health?
That's the key question.
Is it?
Gregory Gray has done a lot of research on animal viruses
Okay.
and how they jump to humans.
Right.
He says that while viruses do jump from animals to people fairly often,
Okay.
it's actually rare for them to adapt
Okay.
and start spreading easily among humans.
I see.
As of spring 2025,
Okay.
there are no confirmed cases of sustained human-to-human H5N1 transmission in the U.S.
Okay, so all the cases so far
Yeah.
have been from direct contact with infected animals.
Exactly. Mostly poultry or cattle.
Okay, so it hasn't spread like a regular human flu yet.
It hasn't, Gray even said,
Yeah.
it's not like in the movies. It's going to take continual spillover events for it to get a foothold
I see.
in the human population.
Okay, that's good to know,
Yeah,
but we can't rule out the possibility of it adapting.
absolutely not.
Right.
Remember the 2009 H1N1 swine flu pandemic?
Yeah.
That virus started in pigs.
Right.
Jumped to people and
Yeah.
spread all over the world.
Right.
It caused a global pandemic, though it wasn't as deadly as COVID-19.
Right.
But it shows how animal viruses can become major threats to humans.
They can.
Yeah.
So what would a bird flu virus need to do
Okay.
to spread easily between people?
Well, it would need to change a few key things.
Okay.
One big one is the hemagglutinin protein.
Okay.
Right now, the H5N1 hemagglutinin likes to bind to a specific sugar molecule
Okay.
that's found on bird cells,
Okay.
and it's also in cow udders.
Which explains the mastitis.
Exactly, and it's also in human eyes,
Okay.
which might explain why some people in the U.S. in 2024 got pink eye,
Okay.
along with fever and other respiratory symptoms. Right.
But to spread easily through the air, like through coughs and sneezes,
Yeah.
it would need to change its hemagglutinin.
Okay.
So it can bind to a different sugar molecule,
Okay.
one that's mostly found in our upper respiratory tract.
Like in our nose and throat.
Exactly.
Okay, so it needs to be able to attach to cells higher up
Yeah.
to spread through the air.
Right.
Okay.
And it would probably need its polymerase?
Polymerase.
Yeah, the enzyme that copies its genetic material
Okay.
to adapt and work better with human proteins.
I see.
Some H5N1 versions have already mutated to replicate better in mammals.
Okay.
But as of now, Thomas Friedrich says none of the viruses from cows to humans have those hemagglutinin mutations
Right,
that we
yeah.
think would make it spread easily between people.
Okay, so that's good news,
It is for now.
right? But it could still evolve further, right? What are the main worries there?
There are two main ways it could evolve.
Okay.
One, it could just keep mutating on its own.
And eventually gain the ability to spread between humans.
Okay.
Or, and this is more worrying in the short term,
Okay.
it could swap genes with a human flu virus
Right.
if both infect the same animal or even the same person at the same time.
Oh, no.
Yeah, this is why flu season is scary.
Makes sense.
Like the 2024-2025 winter,
Yeah.
there's more chance for these two viruses to meet
Right.
and maybe create a hybrid that spreads easily among humans.
That's a scary thought.
It is, yeah.
So is there anything that might protect us from this bird flu?
What